Here, suppose that 10 power 2n minus 1 plus 1 is divisible by 11. This is your statement Pn. You have to prove this statement using the principle of mathematical induction. Step first will be what? P1. P1 equal to 10 power 2 into 1 minus 1 plus 1. That is 10 power 2 minus 1 plus 1. That is 10 plus 1 equal to 11. This implies that P1 is true. That means what? Because 11 is divisible by 11, so P1 is true. Now step 2 is that let Pm is true for n equal to k, where 1 is less than equal to k less than n. So this will be what? Instead of n, we have to put k plus 1. So it will be, instead of n, put k. So Pn is true for n equal to k, that is 1 less than equal to k less than n. This implies that 10 power 2k minus 1 plus 1 equal to 11 lambda for some lambda n natural number. Now pk is what? 10 power 2k minus 1 plus 1 is divisible by lambda. This we have is divisible by 11. This we have supposed, and so 10 power 2k minus 1 plus 1 divisible by lambda may be written as 11 lambda. Now step third, we need to show that pk plus 1 is true. Whenever pk is true, that is, we have to prove that pk plus 1 is true. That is 10 power 2 n k place, at the place of n you may put k plus 1, so it is 10 to k plus 1 minus 1 is divisible by 11. 10 power 2 into k plus 1 minus 1 plus 1 is divisible by 11. We have to prove. Now pk plus 1, 10 power 2k minus 1, because this is 2 minus 1, so 2k minus 1 plus 2. Then it may be written as 10 power 2k minus 1 and into 10 power 2 plus 1. That is, but 10 power 2k minus 1 is equal to 11 lambda minus 1. So instead of 10 power 2k minus 1, you may put 11 lambda minus 1. So this will be 11 lambda minus 1 into 10 square plus 1. That is 1100 lambda minus 100 plus 1. That is 11 taken out common. You will get 100 lambda minus 9, which is divisible by 11. That means pk plus 1 is true. This implies that Pn is true for all n belong to capital N using PMI. Now this is your second question. Suppose that you have to prove that 2n plus 7 less than n plus 3 whole square. This is the statement Pn, that 2m plus 7 less than n plus 3 whole square. Step first, P1, that is 2 into 1 plus 7 less than 1 plus 3 whole square. So 9 less than 16, which is true, and so P1 is true. Now step 2 is that let Pm is true for any natural number m lying between 1 and n. M may be equal to 1 but less than n. That is 2m plus 7 is less than m plus 3 whole square. This is equation number first. Your step third will be what? To show that Pm plus 1 is true whenever Pm is true. That is, we will suppose that equation first is true. Then we have to prove that Pm plus 1, that is 2 into m plus 1 plus 7 less than m plus 4 whole square. So this is 2 into m plus 1 plus 7 equal to 2m plus 7 plus 2 less than m plus 3 square plus 2. So what happened? It is because it is less than m plus 3 square plus 2 by in the view of equation number first. So you will get 2m plus 7 plus 2 less than 2 less than m square plus 6m plus 11, that is m square plus 8m plus 16, because 2m plus 5 is greater than 0. So on adding 2m plus 5 here, this again will be less than the same quantity. So 2 into m plus 1 plus 7 less than m plus 4 whole square, that is Pm plus 1 is true. Hence, by the principle of mathematical induction, Pn is true for all n belong to capital N.